This is one of those stories that sounds almost made up. It's about a scientist who set out to solve one of the oldest questions we've ever asked. But in the process, he stumbled onto a global crisis that was hiding in plain sight, and he ended up kicking off one of the greatest public health victories in all of human history, completely by accident.
So it all started with a question that is just massive, on a cosmic scale. Just how old is our planet? Trying to answer that was going to set a brilliant geochemist on a path he never, ever could have seen coming.
But the thing is, the answer was blocked by this invisible barrier, a mystery contaminant. And figuring out what that was would end up revealing a poison that we were all breathing and eating and just living with every single day.
Okay, so let's set the scene. We're in the late 1940s, and our story is about a young geochemist named Claire Patterson. He was a grad student at the University of Chicago, and he was given a task that was, well, monumental.
His mission, his entire project, was to measure something called primordial lead. This is the specific type of lead that was around when our solar system first got started. And the theory was that you could find this pristine ancient lead perfectly preserved inside meteorites. They're like these little geological time capsules. It was the one missing piece of the puzzle you needed to finally calculate the true age of the Earth.
His mentor, Harrison Brown, was super confident. He basically told him, "It'll be duck soup, Patterson. A piece of cake. Just get a chunk of meteorite, pull the lead out, measure it, and boom, you're famous. Simple as that." Well, as it turns out, it was anything but.
For 7 long years, Patterson was just grinding away in his lab. And for 7 years, every single experiment failed. His results were always impossibly, ridiculously high in lead. He just kept hitting this wall. It didn't matter how careful he was, his lead readings were hundreds of times higher than they should have been. Something was seriously wrong, and he knew it wasn't his theory. It had to be his lab.
And so, this question became a total obsession. The whole dating the Earth thing, it had to be put on hold. The new mission was to hunt down the source of this phantom lead that was just wrecking all of his work.
He started tracking it down piece by piece, and the answer he found was, well, he was everything. The dust floating in the air, the water from the tap, the solder in his equipment, the paint on the walls, and, as he famously found out, even the dust from his own hair and clothes. He realized he was living and working in a sea of lead.
So get this. To answer a huge question about geology, he first had to become an expert in contamination control. He was literally forced to invent the world's first ultra-clean laboratory. He pioneered techniques that are now totally standard in everything from making computer chips to exploring space.
And guess what? It worked. Finally, in 1953, sealed up inside his brand new clean room, he did it. He isolated the primordial lead, he ran the numbers, and for the very first time in history, we knew the true age of our world. And the number was so accurate it's barely been changed since. Now, this really should have been the triumphant end of his story, right? But Patterson just could not shake this one terrifying thought. If his meticulously, obsessively cleaned lab was this contaminated with industrial lead, what did that mean for the world outside his lab?
He suddenly realized the lead wasn't just some annoying little nuisance messing up his data. The contamination in his lab was a microcosm, a tiny snapshot of a much, much bigger problem on a planetary scale. A problem nobody else was even looking for.
So he started digging into the history of lead production. And sure, he found that humans had been using it since Roman times, but its use just exploded with the Industrial Revolution. And then, in the 1920s, things took a really catastrophic turn when corporations started adding something called tetraethyl lead to gasoline.
Now here's where he got really clever. Patterson found a way to measure this pollution over time. He analyzed ancient ice cores from the poles, which are amazing. They contain this perfect frozen record of our atmosphere. And he discovered that lead levels in the air had just skyrocketed by up to 300 times since the Industrial Revolution started.
But his most shocking discovery, the one that just changes everything, came when he turned his attention away from the environment and towards our own bodies. He managed to get his hands on ancient human bones from pre-industrial cultures that had no exposure to metals.
When he compared those ancient bones to modern skeletons, he found the horrifying scale of the problem. We, you, me, all of us, are carrying a lead burden up to 1,000 times greater than what is natural for our species.
1,000 times. Just let that sink in for a second.
You know, a discovery like that, it changes a person. And it changed everything for Patterson. He essentially abandoned his acclaimed geology work and dedicated the rest of his life to a lonely 30-year crusade to warn the world about lead.
He went public with what he'd found, publishing papers showing how lead from gasoline was poisoning the oceans. Well, the response was swift and it was brutal. The powerful oil and chemical industries who had actually funded his earlier geology research, they cut him off immediately. They launched a campaign to discredit him, they pressured funding agencies to reject his proposals, and they got him kicked off of key scientific panels.
But Patterson was relentless. He knew the science was on his side. He spoke with this terrifying clarity about the extreme toxicity of tetraethyl lead. I mean, this is a substance so deadly that just a single drop on your skin is fatal. And we were pumping millions of tons of it into the air we all breathe.
So you had one scientist against some of the most powerful corporate interests on the planet. But he had one thing they couldn't bury, the undeniable truth of his data. And after decades of fighting, the truth finally won.
His persistence paid off in ways that affect every single one of us today. His data formed the scientific backbone for things like the Clean Air Act, which led to the phase-out of leaded gasoline. It spurred regulations to get lead solder out of food cans, to get lead out of paint, and out of countless other products. The result was this massive, dramatic drop in blood lead levels across the entire population, a public health victory that has literally saved millions of lives.
Claire Patterson's story is just such an amazing testament to the power of scientific curiosity. A quest that began with a question about the distant past ended up protecting all of our futures. And it really leaves you wondering, doesn't it? What other critical dangers are hiding in our own data today, just waiting for someone persistent enough to see them?